Hi guys, I just wanted to do a quick video showing you how to actually do a shorter version of what Tyler DeWitt does for molar relationships. Now, normally this is what I would teach you if we were in class. So bear with me. I'm going to explain it all. Hopefully you have watched his videos, and if not, that's okay because he just goes into a little bit more detail about what a mole is and what each thing means. So this is assuming that you have watched the videos, but even if you haven't, it's not that difficult to catch on to what we're talking about, okay? So I'm going to go through all of the problems that he talks about in each of his videos. There are 6 of them, and I'm going to show you how to use my version of molar relationships, okay? All right, so we're going to start with a circle. So for Tyler DeWitt's math, he actually goes ahead and does these things that have fractions, which are called it's dimensional analysis. Now that's what I did in school, but some of the kids that I've taught in the past have had trouble with that. So we just go ahead and set it up as a circle, and it kind of makes it a little bit easier. You could also do it in the shape of a Y. It doesn't matter, but the whole point is that moles go in the center. Okay, now moles are what we use to convert between every other thing in chemistry. So this is the generic way that we refer to any type of substance in chemistry. This is just the generic measurement. So if I have a mole of something, I have a whole, like one part of it, if that makes it doesn't make any sense at all, I know, but he also has a video on moles. Again, he's going to go into a lot more detail because he does these videos for like a living. He has a little bit better setup, so bear with me. But anyway, so we have moles in the center, okay, because that's what is our go-between for all of the different things in chemistry. Okay, we have grams, which refers to mass, okay, and we have liters, which is volume, and then we have atoms, particles, molecules, or units. Okay, so there are certain things what we call conversion factors to get from one thing to the other. Okay, so when we're dealing with grams and we want to convert between grams and moles, we use what's called the molar mass, which you should have done yesterday. If you're watching this when you're supposed to, you should have done this the previous day or already or whatever. And so molar mass is when you add up all of the atoms' masses, and that's what the whole particle or compound weighs. Okay? So that's what we use to convert between moles and grams. Now, liters is 22.4. Now, this is a standard number. Okay, so 22.4 is what you're going to use anytime you are talking about volume. All right, so it's a magic number. Now, atoms, particles, molecules, this also has a magic number, but it's quite a bit larger, and it's called Avogadro's number, okay? A lot of kids think it sounds like avocado. It kind of does. But anyway, we do 6.022 times 10 to the 23rd, and that number goes there. Okay, so that's how we convert between particles and moles, or molecules and moles, or whatever. Okay, so now how you work this is you have your circle, and as you move from inside the circle, which is that moles, then you would multiply. Okay, as you move out, as you move from inside the circle to outside, you multiply. As you move from the outside to the in, you would divide. Okay, so in other words, divide in and multiply Okay, and as we go through these 6 problems that I have for you, which is the same ones, and I did it on purpose, the same ones as Tyler DeWitt, so it just shows you no matter whether you use dimensional analysis or the circle method, which is just plain multiplication and division, you're going to get the same answer. So both work. I'm not too picky about which one you use, but you use the one that you're comfortable with, okay? All right, so the first problem he has, what is the volume in liters of 3.8 moles of CO2? So the first thing you need to do is set out what you have and what you want. So what I have is 3.80 moles of CO2. And what I want is how many liters, okay? And we typically always write down the compound because we want to know what it is that we're looking for. And this becomes important when we're talking about things for chemical equations, which we'll get into later. It will probably be, it'll probably be next week. So just bear with me. It's not as hard as it sounds, okay? All right, so what we're looking at is that we want to go from moles to liters. Okay, if you look here, you put your finger on moles and you want to go to liters. So we're in the middle and we're going out. So we are going to multiply. Another way that you can remember this, and sometimes my kids remember it, is moles means multiply. So anytime you have anything that has moles, that you're given moles, you're going to multiply. And that's really going to happen every single time. Nothing changes, okay? All right, so we have moles. So we have 3.80 moles. And then we're going to multiply by the magic number. I'm sorry, I should have left that up there. The magic number that goes from moles to liters, which is 22.4. Now, when you put this in the calculator, you get a number, and it is roughly 85.12. But of course, because we have to look at sig figs, this is not our final answer. Our final answer has to have how many sig figs. We started out with 3 sig figs, therefore we must end with 3 sig figs. So we have 85.1, and we have to label it with liters CO2. Okay, now Tyler DeWitt does not label it CO2, but it helps if you're doing a whole lot of math. So if you plan on going on in chemistry, you want to make sure that you put that CO2 on there, because sometimes we're dealing with a lot of different calculations, and it just kind of helps to keep it straight. Okay, so that's the answer, and if you'll look, that's the same answer he has on there. So it's the same. Okay, now the next problem that I have, it says 58.6 liters. So we have how many moles are in 58.6 liters of nitrogen gas at STP. He also explains what STP is, but STP is standard temperature and pressure, and we'll get to that when we get to gas laws. But basically what that means is that you're going to use the normal rules, or the magic number, 22.4, for our gas. Okay, for our conversion. So we need to put down what we have, and we're going to put down what we want. So we were given 58.6 liters of nitrogen gas, and we want to know how many moles. Okay, so again, like I said, when we have moles, we multiply. So in this case, were we given moles? No. So we are going to do the opposite. And also, if you want to look at it like this, it says divide in. So we're moving from the unit liters to the moles, which means that we are going to divide. So we're dividing as we move from outside the circle to inside the circle. So 58.6 divided by, and our magic number for gases is 22.4. So you go ahead and put that in your calculator and you end up with 2.616. But again, we can't have all of those digits because we have to look at sig figs. Now, how many sig figs did we start with? 3. So we have to end with 3. So we end up with our final answer being 2.62 moles. And again, I like to label it with the N2 because I am a lab scientist, so I do a lot of calculations all at once, and it just makes me happy to make sure that they're all there. But as you'll notice, he has the same thing, okay? So as you can see, it works the same way. Okay, next. The next one we are doing, we are going from moles to grams and grams to moles. Okay, so this requires that we actually know the molar mass. So you're going to get out your handy dandy periodic table, because I know you guys keep them in your back pockets because they're just the most awesome things ever. And chemistry is so much fun. So this time we want to know how many grams of aluminum are in 4.30 moles. So we're given 4.30 moles of aluminum, and we want to know how many grams. Okay, well, in order to get from grams to moles, we have to know our molar mass. So molar mass is what we get off the periodic table. Aluminum is, and we can round it to the nearest whole number, which would be 27. So we start with moles. Moles mean we multiply, so we get 4.30 times 27, which you will find comes out to be 116.1. Okay, now how many digits should we have? 3. Okay, all right, so our final answer should be 116 grams of aluminum. Okay, hopefully you guys are following. I know it's hard on video. I wish I could be there to help y'all, but I think you got this. Okay, so the next one is 127 grams of sodium chloride to moles. So we want to know how many moles of sodium chloride are in 127.5 grams. All right, so we are given 127.5 grams of sodium chloride. And we are going to find how many moles. Okay, so what we need to do first is we need to find how much sodium chloride weighs. So we're going to go to our periodic table again, and we're going to find sodium. Sodium is Na. All right, now when we round to the nearest whole number, we find that it's 23. All right, and then chlorine is, when rounded, it's 35. So we take 23 plus, sorry guys, 35 is 58. So the molar mass of sodium chloride is 58. Now, we were given grams, and we only multiply when we have moles. M&Ms. So moles multiply. Are we given moles? No, we have grams. So we're going to divide this time. So we're going to take 127.5 grams and we're going to divide by our 58. All right. Now we're going to get a number 2.19827. Okay. And how many sig figs are we allowed to have? We started with 4, so that's how many we have to end up with. So our final answer should round to 2.198. And of course, we have to label it with moles sodium chloride. Okay, so that's that. All right, now we're going to do moles to atoms. Now here's what's going to be difficult, especially when you don't have one of the calculators that I have. So you're going to have to either learn your phone really well, or you're going to have to work on a computer that has the capability. Sometimes you can actually download a graphing calculator or a scientific calculator onto your phone, and that might help you, and they should be free. By all means, do not pay for it, because there's lots of free ones out there. Okay, so the next one is 5.5 moles, and we want to know how many atoms we have in 5.5 moles of chlorine. Okay, so 5.5 moles of chlorine, and we want to know how many atoms that is. All right, so as we look on our circle, we know that the number to get from moles or between moles and particles or atoms or anything of that type is 6.022 times 10 to the 23rd. Okay, again, I called that Avogadro's number. So that's our magic number to get between particles and moles. And since we started with moles, we're going to multiply first. Okay, what you're going to do if you are using a simple calculator and you don't have something with a like 10 to the, or an exponent button, like a times 10 to the whatever button, you need to use your parentheses because you'll get the answer wrong. Okay, so what you're going to do is you're going to take 5.5 and you're going to multiply by Avogadro's number, 6.022 times 10. And then you're going to use this caret button, to the 23rd, I'm sorry. And that's supposed to be a 23, guys. I'm super sorry, okay? But you are going to put that. Sometimes it depends on the button. If you cannot figure out what it is, please message me. Let me know, because I can usually, you take a screenshot, I can tell you what it is that you need to push to get that exponent of 23. But when you do this, you're going to get 3.3121 times 10 to the 24th. And it's going to look funny because your calculator will actually use an E. Okay? It'll use an E instead of a times 10. Okay, so it'll be 3.3121 E 24. Well, your calculator just writes E because that's what it means, exponent. Okay, now you guys understand how to round. Using sig figs, we should have 2 sig figs because that's what we started with. So we are going to end up with 3.3 times 10 to the 24th power. And this is atoms of chlorine. Okay, and that would be our final answer. All right, next. The last problem I have for you with these, okay, with molar relationships, single-step molar relationship problems, is where we have atoms of sulfur, and we are trying to convert 2 moles of sulfur. So we start with 4.6 times 10 to the 24th sulfur atoms. And we want to know how many moles that is. All right, so again, we are going from atoms to moles, so we are going to divide. So 4.6 times 10 to the 24th divided by, and our magic number for atoms, particles, units, stuff like that is 6.022 times 10 to the 23rd. Okay, now it is extremely important that you put these in parentheses if you are not using a fancy pants calculator with an exponent button, because you will get the answer wrong. You may get the number right, but the exponent will be wrong, because you should not get something with an exponent over 23 or 25 or something like that. So if something like that comes up and it's like 48 for the exponent, it's wrong. Anyhow, use parentheses, and when you do, you'll get a number. It's a really long number, but I'm just going to put down the first few digits that I see. Okay, now I can only have, how many sig figs did I start out with? 2, because remember, the only ones that count when you're dealing with scientific notation are the 2 in front of the times. So we only have 2, and we are going to go down here, and we are going to round it to 2 sig figs, which is 7, 6. So I have 0.76 moles of sulfur atoms. Okay, all right, so I know that my camera was kind of like jiggly and everything, and I know that it's really hard to learn this way, but you guys have been doing great so far, and I hope that I've made it a little bit easier if you were struggling with Tyler DeWitt's way of doing things. Okay, so feel free to email me whenever you have a question. Again, remember, here's your circle. If you start in the middle, you multiply. If you start on the outside, you divide. Okay? So if you have moles, when you're given moles, or in the problem, then you need to multiply. If you're not, then you divide. Okay? I will record another one for you, and you guys, it'll be 2-step molar relationships. And again, it's not too bad. Just bear with me. All right? Let me know if you need anything.